This episode of Gauging Quality is sponsored by PQ Systems, developer of GaugePack, the original gauge and calibration management solution. For more information, visit pqsystems.com.
Welcome to Gauging Quality, the show about gauges for those who use them. I'm your host, Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Craig Howell, President of CPM Labs in Rancho Cordova, California.
And today we have a, excuse me, a little frog in my throat. We do have a real good lineup for you. First of all, I want to thank our sponsors, PQ System, for sponsoring today's show. More on them later on. And Craig, what are we going to be covering today?
We're going to cover 4 topics pretty much. We're going to cover intervals that need to be established for gauges that the manufacturer themselves might not establish one for. We're going to cover how to buy used precision hand tools. Also, what to look for in a calibration lab. If you decided to go looking for one, what are some of the common things you'd look for? And we had a question from a viewer asking how to calibrate a thread ring gauge.
Yeah, okay, so a lot we're going to cover today. As usual, if you've seen the show before, you know that anytime during the show you can send us questions at techno-live@qualitydigest.com, and we will get your questions on the show as we go along. And Craig, so what's our first topic you're going to cover here?
Well, let's start off on buying used precision hand tools. A lot of times you can find them everywhere, so what would you look for when you're trying to buy them? Let's start with an OD micrometer. We deal with 3 basic types of tools that people are always asking about: micrometers, calipers, and indicators. And what would you look for? Well, the first thing are the measuring faces themselves, the ambles and the spindle. And maybe we'll move down to the gauge cam so we can actually show you what we're talking about. The amble itself is very shiny when they're brand new. Let me try to get it at an angle you can see. You can see the reflection. Same with the spindle, it'll also be very shiny. Well, a good quick check, because you're not going to have gauges with you when you're looking, is hold it up and make it reflect a light grid on a ceiling panel. It should reflect, it shouldn't be all burnished and dull, and the lines should be straight and square. If they are, you've got a pretty good indication that it may be one worth considering. If they look like a beach ball, pass it up. Immediately pass that up.
I mean, can't you replace the anvil and the spindle though? I mean,
they can be reground, but that would negate the cost. The cost would be between buying the tool and redoing it, the cost would be similar to buying a new one.
So even though they're replaceable parts, if you have to replace them, you might as well buy a new one.
You might as well buy a new to start. Another feature you might want to look at, and regarding on the gauge cam, would be the spindle lock. Most of these, you lock that and the spindle will not turn. You unlock it and the spindle turns freely. So you want to make sure that it works and it's there. A lot of them get broken. That's some of the features. Another thing would be, on the back end, there's usually some sort of a mechanism. This is a friction thimble that when it gets to the measuring point, it'll stop and this will apply just the right amount of tension. This is great when multiple people are going to use the same tool. You'll get the same reading if they all use this. If they're just using strictly the barrel, some have a heavy feel, some have a light feel. This is a nice feature to have.
So you're looking at more as just a feature?
Right. Okay. It's a feature to consider, but it makes the tool more valuable to you, something you might want to consider. Next type of tool might be a digital micrometer. A lot of people love the digital micrometers. They have some features analog won't have. One of them, this one doesn't have, but a digital output, which would go into a lot of the different software. Our sponsor today has some software this would be very handy with. You can do Gauge R&R, sometimes your inspections. You can hit a switch or foot switch, whatever the case, put it into the software, you've recorded the value without having to put it down, write the value down. Very handy tools. Digital have their own pitfalls, mainly electronic. If they tend to get shocked or zapped if they're left on a table, a welder might be working on something of that nature, they're going to be useless. If the digital display doesn't work, usually needs a new battery. But if the new battery doesn't do it, that would be something you could bring, is the typical 357 batteries. They're going to power most all of these. So I'd bring that.
And also, I'm guessing that if you are looking at a digital gauge and it has a digital output, you want to make sure that output works. So bring your
laptop and your cord,
or whatever.
If that's what you're looking for. Not everyone's going to have that, but if you're looking for a digital output, yeah, bring the cord, bring the laptop. The LCD displays on these and on calipers, and even there are some indicators now that are digital. If it's been hit hard, a lot of times it'll look like a black ink pen has seeped into it. I'd pass that up. That's something you're going to have to replace the display. It's going to cost that in the purchase of a used. It's going to be the same as a new one. So the display's working, the spindle lock works, the faces are clean. Those are the types of features. I just visually would try it throughout all its paces. When you tighten it down, if you give it a little flick, does it freewheel? Does it just keep spinning? That's too loose, it'll need adjustment. All these adjustments can be done, but they all add up. They all take time and they add up.
So you should run this all the way through the full travel.
Through the full travel up and back.
And you're looking for it to feel rough or that sort of thing?
Opposite. You're looking for a smooth feel. If it does have dirt or grime inside, it'll tend to snug up or stop. You wouldn't want that. On analog, you want to make sure when the 0 is right at the number that it lines up. Let's go to the gauge cam and I can show you a little better here. Right when the 0 has lined up, it should just cover the line. In this case, it's the 0.6. You don't want it halfway between that and the next line, or you can't really tell which number you're looking at.
Okay.
So that kind of covers OD mics, just a general broad overview. Second type of mic we see quite often is the blade mics. They have a very thin measuring blade surface, which are great for getting into very thin areas or measuring that sort of thing. Where these would wear, again, is typically on the Amble. We'll get them after we clean them totally. We'll shut them down lightly and we'll hold them up to light and look. If you see a V shape at either end or a groove worn in the middle, pass them up. They again can be resurfaced, but there goes your cost.
Savings, yeah.
Spindle lock, like all different methods of friction or ratchet thimble, that sort of thing. Here's kind of a unique type. It's called a disc micrometer. It measures just like a normal OD, but the actual measuring faces are quite large. They can fit out and measure a flange of something sticking out where the body might hit on a normal one. These can get into areas that others can't.
Yeah, can you show? I've never seen one of these before.
On the gauge cam here. And these have the different measuring faces.
Oh, I see. So yeah, it's a real big flat disc. And do they come with bigger discs?
This is about the largest I've seen. Okay. Some come with a little smaller disc, and the discs are what you're going to want to watch for. When they sit down, they lay on that blade. You're going to want to look for dings and nicks. Flatness is the same specification as normal, so you got to make sure they're very, very good shape or don't even consider them. On most, when you close a micrometer down and hold it up to light, you're not going to see any gap. But on these, they're large enough, you might be able to see. If you saw a gap, you'd pass it up.
Okay, so the same idea, you would bring them all the way down closed, hold them up to the light and see if you can see in between them.
Correct. The last type of mic that I'm going to cover today is a multi-amble mic. A lot of machines call them pin mics because usually a pin is used at the end. It's round, so it's great for measuring to a rounded hole. You have tangent to tangent. They'll have different pins. Usually in the box you buy them in, they'll have a couple different sizes of pins. The pins get very, very worn and bent. You're almost better off to start with fresh pins, which can be made of, I've seen them made of drill bits, you name it. Anything that is very straight and true, but that is what will wear on a lot of them. A lot of times you can hold these up again to a light, and here you might see the pin contacting at the bottom or the top. It's bent, get rid of it. But that's not a reason to pass this type of micrometer up. That's a very minimal cost to replace.
So it might make sense if you're buying a pin micrometer and I'm assuming the pins are really inexpensive, is just get rid of the pin and just
start off fresh
because they're cheap, yeah.
Now let's go back to the gauge cam. Some other features you might want to look at. The actual clamping mechanism. You'll know when you saw the mic originally, it should have a pin in it. You'll know everything was there and complete. But that removes, and you can actually use these mics almost as a reverse depth mic. It's more of a stepped height. But the surface here is something that you'd want to consider. This surface here has to be very, very flat. If it's grooved from a pin sitting in there, pass it up, because it'll never sit flat.
And this is like the anvil on a micrometer. This is a precision surface.
It is. It's not held to the same spec, but it is a holding area, so it has to be kept in good shape.
And that's why you can use it as a reference base.
As a reference base.
Okay, all right.
Correct.
Interesting. Okay.
Next things we'll cover are calipers. The typical are your dial calipers and your digital calipers.
Now, a lot of people, people use calipers on, that's probably the most common tool you'll see out on the shop floor, or calipers, and probably people want to, do you always have to pop for a new one, or I'm guessing these come up for sale fairly often.
They are, and there's
there's
some excellent brands. This is a dial caliper. We'll cover this first, and we'll cover digital. The main wear points on any caliper, no matter whether it's dial, digital, or vernier, are going to be the actual measuring surfaces, and they get worn at the outer tips. A lot of times they'll be used on sheet metal, and they'll be moved back and forth. You'll see the wear. Again, we clean them, hold them up. We do a lot of holding up to the light, and you'll see the wear. If you see wear in it, pass that up, because there are 1, 2, 3, and sometimes 4 measuring surfaces all connected. So you can't correct one. It's not like that. The exception is the depth rod. The depth rod on these, a lot of times, is held in with a screw, and it'll allow a certain amount of adjustment. So then, of course, mechanical. These have a metal rack installed in them that the gears ride on. Current models, the rack is up on the top. Early models that had a lot of problems, the rack was on the bottom.
Why was that?
Because machining chips, metal chips, and coolant and dirt would get in that rack and cause the caliper to skip. Now the hand's off.
Oh, because the rack was facing up, so you're normally holding it that way, so stuff is falling into the
stuff is falling into. So manufacturers now have all gone to the top. But early models with it on the bottom, I'd pass those up, because those are going to be problems.
Yeah,
they're going to be problems. Dirt and grime in mechanical calipers are what are going to ruin them. Also, with calipers and indicators, a lot of times you'll find coolant right inside. I had one indicator I replaced the faceplate, and they said, "Why'd you replace our green faceplate with a white one?" I didn't want to tell them they are white. Look very carefully inside. Let's go to the gauge cam. On the actual dial, there's a crystal, which is the glass piece above it, and then the dial below. Look for lines and wear which might indicate rubbing, that the hand has been rubbing one of the two. The hand itself, make sure it's straight. We've seen some that had some very artistic curly cues in them. I can imagine how that might have happened. Main thing we look for is for them to repeat 0. When we shut them, they should go to the same place every time. If they don't, there's gears inside. They probably lost their preload, or it could be worse.
Now, I was playing with this one earlier, and noticed that the feel. I was just this is like glass. I mean, would that matter? I mean, would you be looking to see how this feels when you're running it in and out? You would,
and you would look for glitches and ticks and nicks, and suspect there's probably something in the rack at that point.
And again, something that you would just pass on it, just figured somebody, even if it was possible to clean it, maybe they weren't taking care of it properly.
It would depend how bad it was, but that's not a good sign.
Yeah.
At least that should lower the price some, at the very least. So that's a dial caliper. Digital calipers are next. They don't have the mechanical movements inside. They work on encoders and that sort of thing. So it's a different feel. They really only contact top and bottom, and that we adjust. There's a little gib inside of both of these, but these have a different feel. The main things that wear on these, of course, are the jaws. The jaws always are the wear points. But the digital display itself, that is if it's not working, of course, you have your new battery to put in. If it still doesn't work, pass it up. The electronics to replace them, you've now bought a new caliper, basically.
And kind of thing I hear you saying pretty much on all of these is, because they're all mechanical, they all move, is you want to, the first thing is, how do they feel? How does everything, whether it's a micrometer or a caliper, how smooth are they, right?
How smooth are they?
How clean are they? I mean,
clean's a good thing.
Because it kind of indicates they're being taken care of.
It does, and clean's no guarantee that they're bad, but if they're all dirty and grimy and there's metal chips, especially with mechanical ones, that's nothing but trouble.
Okay. And the contacting surfaces should be smooth and flat and parallel.
Contact surfaces are your main focus. They have to be straight. One thing you want to consider with calipers, sometimes right in the middle, all of a sudden it'll get very tight. And a lot of times these have gotten banged around in machinery and the frame is bent. I would pass it up. If it slides very smooth, tightens up, and then slides smooth again, you have probably a bow. There's no guarantee, but that's usually what we found it is. And when we question the person, they say, well, yeah, it did get caught in the machine and got thrown.
we did use it as a screwdriver.
Last type.
Actually, while we're on these, let's. We had gotten a question, and since you have both a digital and an electronic caliper here, let's. We got a question from a reader I'm going to throw at you here.
All right.
If we can put that one. This one came from a Robert B. There we go. I'm a little old-fashioned and prefer to use dial calipers over digital. What are some of the pitfalls and measurement errors that can be attributed to the use of digital? And again, that was from Robert B., who sent that question a couple weeks ago.
Okay, Robert, you need some ammunition here. So probably you prefer the feel of dial calipers. Dial calipers have a feel to themselves. Like Dirk said, they're smooth. A lot of machinists, a lot of engineers, they just like the feel of a dial caliper better. Number one pitfall of digital is the electronics. You'll never have a dead battery with a dial caliper. You can be shut down with a dead battery here. If you don't happen to have a battery, you're out. Mostly the pitfalls will relate to the electronics. If this is left on a welding table, we see a lot of calipers and height gauges that are on metal tables when a welder has come by and done some welding, and they can't handle the shock.
So you're saying that they're using, let's say, a height gauge to inspect a part on the welding table. They forget to take the height gauge off and start welding again. And
they set something up, they tell the welder hit it, and they forgot they had the height gauge right there. So if the electronics get zapped, or again, that bleeding of the LCD, the black, make sure the digits sometimes don't work. You can't tell if you have a 3 or an 8.
Oh, right. Yeah,
That's real common with any of you know digital device. They're like that. When the digits go bad, that's not going to work. Other than that, their accuracy on the 6-inch, the accuracy is going to be the same on digital or dial.
Well, wait a minute. I thought people could like on a mechanical gauge or on a dial gauge, you could kind of read in between the digits, right? A digital is just going to give you
0
a number,
or 5.
but I mean, I can guesstimate that that's 1.5 units, right?
You can read it, but the accuracy is 1 division. So you're not doing yourself a favor to say that's 125.4 or 125.5. It's not helping you any. You can read it, but what you're resolving with your eye, what you're reading, the accuracy is not there. The accuracy is 1/1000th of an inch on either set. So it's 1 division on the dial, and it's actually 2 increments on the digital.
And I will say, one of the, a couple of advantages to me, at least for a digital, is number one, they're easier to read.
They are.
I mean, they got big displays, and as you're getting older, okay, I can almost read that. I don't have to put my glasses on to read these. And also, I mean, almost any more people are taking their readings directly from their calipers or their micrometers and taking the electronic readout from these, bringing them into software, either for logging their measurements, or if they need to do some sort of study, it prevents having to transcribe and stuff. So the electronic output, I think, is, if you don't use it, I guess it doesn't really matter, but that is something that we're seeing more and more. I mean, almost everybody's trying to log their measurements. Although I guess, out on the shop floor, it's probably a matter of preference, right? I mean, which one do you like?
True.
They're just as accurate, so.
Just thought of another one. Out in the bright sunlight, sometimes LCD displays are hard to read.
Oh, they'll turn black.
I don't know how often you're measuring with calipers out in the sunlight, but I'm working with you. I'm trying to find these advantages. You can always read a dial caliper. You won't have any doubt. You can always see that needle.
Right.
They've made them bright orange to help you on some. So those are calipers, and that would be some of the advantages of, as the calipers get larger, you don't typically find dial calipers larger than 20-inch, sometimes 24-inch. I'm trying to think if I've ever seen a 36-inch dial. I don't think I have. Okay. I think 24 is about the limit. After that, it's strictly digital, which really excel then. Their tolerance is fantastic. Some of these carbon fiber calipers are light. They're 4 feet long, and they're great to use. Or the old vernier calipers, which a lot of people don't really know how to read a vernier anymore, but they're affordable. They don't cost as many thousands of dollars as some of the digital counterparts were.
Now you have a couple of indicators here too as well.
Talk about indicators next. The 2 basic type are travel indicators, which the actual stem travels a distance, so you can measure quite a distance, sometimes up to an inch. And the dial, the hand goes around several times. This one goes around 2.5 times. and travel indicators, which have this is called the contact points, the measuring surface that'll stick into grooves and notches. People use them for measuring run out, that sort of thing. Let's cover what to look for in them. We'll probably start the gauge cam. I'll start with the travel indicator. This has a stem, and we would always start by running it through its full motion, especially on the way back. Look to see if it sticks or if it hesitates. It could just be dirt, but it could be the wrong thing. It could be a bent stem, and that would right there, I would not buy one that didn't do that. Also, when you let it stop, is it stopping at the same place every time? Because that actually, the repeatability, it's always done under load. They will always do it under load. They'll never do it at zero, but it has to stop at the same place each time. These also, as any indicator, have a removable measuring tip they call the contact point. They come in different lengths, and on these, length doesn't matter. On these, you can use any length because it's measuring straight up and down in the same direction. Length won't matter. We always look right in this area for a large buildup of dirt or crust because that's going to affect things. Make sure it returns. These have a clamp which when loosened, you can rotate the dial, and when tightened, it holds it down. A lot of times these clamps will break. See if there is one. They'll all have a hole in there, but some of them will be missing the clamp. See if the clamp works. Sometimes it's there and it's busted off. So visually, you might think it's working, but it's not actually doing what it's designed to do. Next will be the test indicator. This one typically will just rotate one division. Interrapids go around 2 divisions. Or they'll actually go, usually 2 divisions. This one will just go around 1 division. You'll notice each of these will go a little below 0 and a little above 0. You always want to set 0 up a ways so that your measurement is always taken under a load. You never want to end your 0 here. Number one, you can't tell if the dial would have kept going, if the needle would have kept going. You always want it to be under a load so that when you hit 0, you can see if it goes below. And it's spring actuated, so it needs to be under tension.
So again, you're also kind of feeling or looking for smoothness. Yeah.
Smooth movement. These will really tend to not repeat when they go bad. You won't get the same final 0 point. That's a good check. We check them both from above and below. We'll look at, usually these have screws. This is a little different type. This is a compact indicator, but most of them will have a little adjustment screw. Look and see, are the screws all burred up? That means someone's been in there adjusting that really might not have known what they were doing, or they wouldn't have left burrs on it. Check for buildup in here. These screws are usually ball bearing screws, so we try to wobble this back and forth and make sure it does not move back and forth. If it does, those ball bearing screws are either not adjusted right or they're damaged.
So that shouldn't have any play left to right.
It shouldn't have any left to right play. Okay. Last thing to consider would be the contact point. The contact point is the most replaced part on these. They wear on the top and the bottom because of how they're used. And bring a magnifier with you. If you look through a magnifier and you see they're worn, that contact point is going to need to be replaced. So maybe factor that into the cost when you're buying it.
If the gauge itself seems fine, but it's just a contact point, then you could still be getting a good buy. You just need to replace that. Okay.
Now here's a different indicator, and you'll notice the length in the contact point is quite a bit different. Contact points are specific to the indicator. Even if it fit on there, you could not put this long contact point on this one or the short one on here and get an accurate measurement. It's all, it doesn't vary. Once they're a fixed length. Once it's made for one, that's the only length that'll work.
So if somebody has for sale an indicator, and they say, and look, it has all these different tips with it too, and you've got a 1/4 inch tip and a 1/2 inch tip and a 2 inch tip, you might be suspicious?
That's a clue. They might not know what tip goes on there correctly, and that's not something you could field check unless you happen to bring standards or in controlled.
Or you knew the model, you could look up the model number, would tell you what tip, right? I mean,
right. You know, most of the Brown & Sharps are going to be a 1/2 inch.
Okay.
They're right around there, although every manufacturer seems to make one with the long one, so you would have to know the models. It'd be almost impossible.
Okay.
One clue might be if they have 3 or 4 extra contact points with different ball diameters. If they're all the same length, it sounds like they probably have the right one.
Ball diameter can change, but the length has to be fixed.
Cannot.
Okay. Right.
Another thing to look for is if it's in a box, what comes in the box? What kind of goodies did they have with it? These are all mounting hardware you're going to need, you may have, but you may not. So it's always, you can't have too many of these mounting. And also make sure on the indicator to check the mounting surfaces. Are they burred? Will these actually fit? I try them on there and make sure they fit. Some American dovetail clamps will not fit the foreign ones, the either Chinese or European. So it's not a definite fit. Make sure they fit and they work.
Okay.
So that covers the 3 types of tools we were talking about.
So to recap, basically it's cleanliness, smoothness of movement on everything, and on the on some of these indicators that they return to the same spot.
They return to the same spot. Same with calipers, and always the measuring faces. What's actually doing the measurement? What's the quality of that? Yeah. If it's a micrometer, is it flat? If it's a caliper, is it flat or grooved? If it's an indicator, if it's a ball, make sure the ball is round. Bring a magnifier with you when you're buying any of these. If nothing else, you'll scare the seller a little bit.
Okay. Before we go into the next section, if you've got any questions about anything that we've covered or any questions related to gauging come due during the show, just send them to us at techno-live@qualitydigest.com. You see at the bottom of your screen there, and we will get them onto the show. Next up.
Next up will be if you need to establish an interval for calibrating a certain type of tool, and the manufacturer himself doesn't specify the interval. Let's take a freezer or an oven. Your calibration or your quality program, if it demands that everything that you use to accept the product or some certain key processes that they be calibrated and in the system, you have to establish an interval. What's the right interval? If the manufacturer themselves doesn't have anything published in the owner's manual or that sort of thing, how do you go about doing that? Well, the first thing I would do if I can't find it on the manuals, I call the manufacturer themselves. They've likely had that call before. I call for tech support or customer service and tell them the issue. I'm in a quality program. What interval would you recommend that we calibrate this at? And they've likely gotten that call. They might have something they don't publish, but they say you should do it yearly, you should do it biannually, whatever the case.
And if they scratch their head and go, calibration, what the heck are you talking about?
Then, and that happens a lot. We get that with some of the tools that might be included in this might be a kitchen timer. A lot of people use kitchen timers at work for their process. They say, it's 10 minutes, it doesn't matter. Well, their quality program says it does matter, so
you gotta put it calibration.
What do you do? For larger equipment like ovens or freezers, that sort of thing, first thing we do is turn to the manual to the maintenance section and see what the preventive maintenance is called on that. What do they recommend? 6 months, 3 months? That's a good clue. Seals of freezer doors, how often do they say to defrost it? This is going to give you an idea of when the manufacturer knows their equipment's going to be needing some sort of adjustment. So that might be one method, would be that. You could also consider other manufacturers of a similar type of tool. Do they recommend a calibration? You're kind of substituting in, which can be that can have some pitfalls, but at least you have a basis to go on when you're asked, how did you establish it?
And by the way, the reason you got this question is you had somebody who was actually a calibration on
a welder, I believe it was.
And a welder, yeah.
And we looked up the manufacturer and model, and we didn't see anything. A call to the manufacturer, they didn't suggest an interval. Then we would go with the preventive maintenance as the basis. We get an idea there. Don't put it on a 5 or 10 year interval. Put it on something more realistic, maybe 6 months. If you have no other way and you have to establish it on your own, where do you start? We start with the design of the tool. How robust is it? How much does it drift? Does it have any history of needing repairs? That's a clue. If they repaired it and a year later it needed another repair of the same thing, a year is too long. You're going to want to catch it. The idea for an interval is to catch it before there's a problem, but also the other side of the coin is to get the value out of what it costs you to calibrate it. Have it out there as long as practical, but you want to catch it before there's a problem. Otherwise, now you've opened up a whole new nest of worms. So. Right. That would be a good start, would be preventive maintenance. We would consider that. Maybe some of your associates use a similar type of equipment and they have established intervals. When we can't find intervals or procedures, we have a database called GuideEp, which is Army and Navy and Air Force and large aerospace companies all contribute their procedures and their documents. We've gotten clues on all kinds of equipment that typically the public doesn't calibrate. Army and Air Force and any of the military, they're going to have everything on an interval. They have to. Aerospace especially, anything that's people-oriented, there are people flying in them, they will have procedures. So that's where we get some of ours when nothing else exists.
So speaking of calibrating oddball equipment, I think that's a nice segue into your next segment here. Is we're talking about you're buying your own tools even though they're used. So the plan is you're going to do all these maybe calibrations and measurements and so forth yourself. But a lot of people don't want to do that. They want to send their equipment out to be calibrated, right?
That's true. A lot of times they will want to send it out. They've gotten too busy where they cannot control their own calibration, or their facility won't allow it, or their customers say, no, you need to have third-party calibration. How do you choose a calibration lab? What steps would you go through to make sure you're looking at a real calibration lab that's going to do the job you're paying them to do? So we could go into that now. How would you choose one? There are three types of services that typically this discussion would cover. One would be a fixed calibration lab, an actual laboratory. The other would be for a customer that needs you to do it at their site. They don't have enough tools to have it gone for a few days, so that would be a mobile lab, might be a method of doing it. And the third situation would be large, heavy equipment, the surface plate, the freezers, the ovens, things that don't move. You have to calibrate those where they sit. That's just the reality of it. So let's focus on the first two immediately. Would be a fixed calibration lab or a mobile. When you're doing measurements in the 5th and 6th decimal place, the 10 million, tens of millions, or single millionth, nothing will beat a fixed calibration lab. We're talking the hallmark of them is their environment. It's 68 degrees, and even more important to me is the stability. They should have a temperature chart recorder on the wall showing the stability of that lab, and that's where our accuracy, that's the basis. Or I could go the other way around and say that would be the basis of inaccuracy if it's not stable.
So I mean, you mentioned variability. So the although the labs are normally kept at 68 degrees, it's not the 68 degree. That's more for consistency from lab to lab, but it's not so much the 68 degrees as it is
the stability.
How much it varies. Is it going from 65 to 73, that sort of thing, right?
That's true, and we'll talk about that. In my world, in the metrology world, we run into this term coefficient of expansion, which is the way materials grow and shrink at different temperatures, and they do it at different rates. Ceramic does it differently than steel, and steel does it differently than aluminum, and a lot of these tools may be of one type of metal and your standards are another. If they come in warm or cool, they're going to be expanded or cooled at different rates. As long as you leave them together long enough in a stable environment, it's negligible. It gets to the point everything is settled down. Your measurements are accurate. And
so that's one of the things you're going to look for in a fixed
fixed lab, in any lab. Any lab, you're looking for stability because that's where the key to precision comes in. Different parameters. If your tool measures 1/1000th of an inch, than if your tool measures 1/1,000,000th of an inch. 1,000th of an inch stability is not going to be nearly as critical as millionths or 10 millionths. They'll run all over the place if it's not stable. So what I would look for in a fixed lab would be a temperature chart recorder and records. Ask them to look at past week's records and watch their reaction. If they come up with the charts, that's great. You can look at them and see how is it tracking. If it gets real quiet, you may know that they're not quite sure how to answer that. Some will have digital nowadays instead of chart. We use paper charts just because that to us works the best. Some will have digital, but how long do they store it? Do they back it up? Does it just replenish and erase it? You'd have no way to backtrack, and we do get asked that occasionally.
Where people want to see the temperature.
They want to know what it was when we did their gauge blocks a month ago that came up in their audit. Their auditor asked and said, well, how can you prove to me? Well, we can point to that hour on that day and say, here's where you were at. Here's where we were at. The actual staffing of the calibration lab, whether it's fixed or mobile or otherwise, from the front office, how the tools come in, how are they logged in, how are they handled, prepped and cleaned, the technicians doing the work, how were they employed? Was it the lowest wage they could find, or was this somebody who's very specialized? You can tell by looking once you go in. You can see the people that are working, how they are doing. Are they adequate? Are they really well versed in what they do? Do they seem to know the tools, or is everything cluttered and dirty and quite a mess? That would be a clue.
Right.
All the way to how are the tools prepped for shipping? Are they going to arrive to you safely? And even the best packaging sometimes can get thwarted. But
so they should be able to show you all that. They should be able to show you records. They should be able to show you
personnel and answer your questions. Another concern would be customer service. That is so important. Sometimes the tool's scheduled to come in, all of a sudden it's a time crunch. You need an expedite now. How long does it take you to get to the person you really need to make that happen? Or if there's a special request, a special temperature checkpoint a customer needs, can you get that information, or are there too many layers between you and where you need to go? It might be the technician, it might be something that can be handled up in the documentation, but how hard is it? That's hard to qualify up front, but it would be a question you could consider.
And what about the mobile labs then?
Let's go over to mobile labs now. Mobile labs have a great purpose. When it needs to be done on site at the customer's facility, they only have one tool. They can't afford to be down. That has a great function of a lab that can come in, get your tools out there, clean them. There's going to be a certain amount of time the tools take to get to the right temperature, no matter where they're being done. So, okay, we'll keep it on the positive at this point with that. They're calibrated, they're returned to you. It didn't even take a day, so your impact is much less. The challenge for mobile labs would be the stability of the temperature.
Well, I was going to say, would a valid question to ask them is, how do you deal with temperature stability, or do you soak? Are you going to soak my hand tools before we calibrate? And for how long? I mean, I would think there would be a whole slew of questions kind of related just to the whole temperature thing in a mobile lab, right?
There is, and it also involves their equipment, their standards. Their standards and their equipment are going to take a certain amount of time to come up to temperature and get stable. In the heat of summer around here in the Sacramento Valley, we'll see 110 degrees, no problem. In winter, outside temperatures, the foothills, or we deal sometimes up in the Lake Tahoe area where it'll get in the minus degrees. It's going to take time for these tools to acclimate, and the standards in the mobile lab. Now, I don't know all mobile labs practices. I don't know if they run air conditioning and heating 24/7 like a fixed calibration lab would. That's where the stability comes in. If they just get in the morning, turn the key on the truck and turn the air conditioner on, and when they go home at night, shut everything down, you've got quite a few hours of fluctuation.
Now, you mentioned earlier that one of the criteria is the accuracy that they're calibrating to. So, might a mobile lab specify that we use our mobile lab for calibrations within so many.
It's a good point.
So much accuracy. But if you want more than that, well, you're going to have to send your equipment to our fixed lab or whatever.
That's a good point.
Because
that would work
with the larger tolerances. You could have more temperature variation without really seeing an impact,
anything. Right? Okay. It all involves the uncertainty of measurement, which is something that stability will help with, or it'll fight you with, depending. Okay. So that's a good point, and they serve a very useful purposes. I'm not trying to do a dig at them. It's just the variation of turning them on and off. That wouldn't work for me.
Right.
The third situation might be when equipment has to be calibrated where it sits, on site, where it sits, large surface plates, things like that. We do have horror stories of open warehouses by the door where papers are blowing in and out and they want us to try to calibrate a surface plate, or equipment that's sitting half in the sun, half in the shade, and they can't understand why their measurements are all over the board. Those are pretty obvious, but you do need to consider our uncertainty of what we're providing on your tool is tied to your environment. We'll do height gauges in areas where punch presses are vibrating and so much we can't get a stable measurement. Or every time the train goes by, which is about every 15 minutes, all work has to stop because everything vibrates. Those types of things, you're aware of them at your lab, but you need to have realistic expectations of what we can do with the equipment if we're subject to that.
But so what would be the questions that you would ask if you've got equipment that has to be calibrated on site? What would be some good questions to ask the calibration lab to kind of see if they know their stuff when they're going to come out to your site?
You could ask them, what type of environment are we going to need to do that? If they say, oh, we'll just do it just right where it is, no problems, it should be fine, I'd question it. If they say, you're going to need to shut the doors for a little while, we're going to need to get everything to calm down, some kind of stable temperature, the time of day might make a difference. If a calibration lab is thinking along those lines and saying, we really don't want to do this in the heat of the day, they're at least considering that. They've got a handle on what's going to happen as those temperatures rise.
So I would think that what you would expect when you're interviewing a potential calibration lab to do in-house calibration is that they should be asking you, what's your environment like? Or whereas if they don't ask that would seem like, wait, well, how come they aren't asking me where my equipment's at?
That's very true.
Or do I have vibration or forklifts running around?
Right, yeah. And that it shows their level of detail, where they're thinking. One topic I want to touch on is how long does it actually take to calibrate a tool? We hear a lot of stories of people wheeling out 50, 60 items into a mobile lab and an hour later returning them all. If you think it's too obvious what the answer is there, but if you think of what's involved, we have to take down the data, the manufacturer, model, serial number, range, resolution. We have to look up the tolerance of the tool, clean it. Cleaning takes a major amount of our time, is cleaning. You can't calibrate on dirt. So we'll run it through its paces, then we'll actually record the data. If we need to adjust, we'll do the adjustment, then we have to run it again, record the data. You have to tag it. It takes longer than 1 to 2 minutes to do that. There's no tools around that can be done that quickly. So I'd consider how long they're taking to actually calibrate your tools. That's a great indicator of what's happening.
Let's move along. We had a question related to ring gauge calibration, right?
Right. We had a customer say, how do you calibrate thread ring gauges? So we're going to explain that. There are 3 different basics to it. First of all, we say that's best left to a calibration lab, but some companies have to do it. They have to have that capability. So to calibrate a thread ring gauge, the first part would be the standards that we're going to use. The second part would be environment. Environment again. And the third area, first we've got the standards, the environment. The third area would be a good solid technique. You have to know what you're doing. Let's start with the equipment. This looks like a normal thread plug gauge. That's what visually it looks like at first till you start looking closer and you find this is a thread set plug. It's totally different than a thread working plug. This is never used to judge a hole. You never thread this into a hole. It's not made like that. I'm going to go over to the gauge cam and get a kind of a close-up on this. The threads are ground all the way, like a normal thread, but the first half had been cut down on the outer diameter. It's a little smaller on the first half than on the back half, because you're actually setting the ring to the pitch, which is halfway up the V. And when you set it on this first half, you're guaranteeing that you're setting it on the pitch. If you were on the back and you were to adjust it, you could be setting it, it could be crushing down to the point that it's actually contacting the outer parts of that thread, and that wouldn't be the way you set it. You always set it right on the pitch itself. Okay. Now these gauges being adjustable, you can take that round thread, and if you keep adjusting it, it's going to get elliptical. It's going to be eventually like a football. This type of a gauge will show that. You'll set it to the front and get it smooth. You know you're contacting the pitch right in the middle because the outer ones are ground down. They won't touch no matter what. Once that's accurate, you'll thread it on to the back half and it'll stop right away if it's worn to that elliptical shape. It should go all the way on and off with the same feel. That's a clue you're adjusting to the pitch and you're not contacting the outer portion. So that they're adjusted to that. You need a separate type of thread gauge for every different size of thread and every different class. It's not like working plug gauges where the go gauge is the same on both the class 2 and 3, only the no-go differs. Ring gauges are a different animal. Class 2 ring gauges have a different pitch than class 3. You have to have a plug for each one. So it gets pretty expensive unless you only deal with 1 or 2 types of threads, then that might be feasible. After that's done, you're going to use, I'll go over to the gauge cam again. We're going to use a couple precision pins to check the minor diameter of this. One pin should thread in, or should fit in all the way smoothly. The other pin's just a little larger and it should stop. It should not go in. It's a go, no go type of check. But you'll get this to where it fits right. If the other one does fit in and shouldn't, you're going to have to adjust it till that won't happen anymore. Then you're going to go back to using the set plug, and you're going to do a balancing act between the set plug and the cylindrical pin. Some people use an intramic, some way of measuring that minor diameter, because that's specified. After all that is done, what we're going to do is check for bell mouth, which as these gauges are used, especially on the ends, they'll tend to wear in a bell shape. Most of the wear will be at the surface and it'll taper down to good. It'll do that depending if you reverse it on both ends. And that's how no-go gauges get rejected a lot. We're always asked, how do you reject a no-go gauge? We use it. It's not supposed to go on at all, or if it does, it can go up to 3 threads. You have to feel resistance by the 3rd thread. It typically only goes on a little ways, so it's worn and worn and worn and worn. And they say, well, tighten it down a little more so it feels right there. That's not how these are adjusted. You have to go all the way on the thread and make the adjustment. It has to be all the way through. The ends get worn out, and that's how no-goes end up getting rejected, because we always get that question, how could they possibly be bad? Yeah. And I understand, but that's how they wear. So then after that, the last thing we would do is the adjustment itself. There are 2 adjusters. One is the threaded adjustment and the other is the lock screw. You'll thread it down, and when you tighten the lock screw, it gets a little tighter. So you've got this, you thread it on. Here's where technique comes in again. You've got to leave it just a little loose, so when you do the final tightening, now it's perfect. And that takes some feel and some trial and error.
Yeah, know how far to back off before you tighten it.
Before you tighten it. Then you'll seal the ends so they're tamper-proof, so the auditor or your customer knows these have not been adjusted in between when they shouldn't have been. So that covers how to calibrate a threaded ring gauge and why we suggest that it's left to a calibration lab. But if you have to do it, that's what you should consider.
Well, hopefully that answered. That was a question that we got, and hopefully we'll get that person is watching. If not, I'll send them a link and they can watch the video here. Watch it. Okay, we had another question come in during the week that asked about calibration and gauge R&R studies. And we're not experts on that, but we did manage to bring in an expert on gauge R&R and kind of how it relates to everything. And that would be Eric Gasper from PQ Systems. And he's going to join us via Skype right now, I hope. Is Eric there?
Hi, Dirk. Hi, Craig. Thanks for having me.
Hello there,
Eric. Okay, so let me just. I think we've got the question. I want to throw it up there for people to see. The question we originally got was, can you cover the pros and cons of calibration versus a gauge R&R study? What is the effect of each of them on product quality?
Okay, for a calibration, the biggest question that we're trying to answer is this gauge accurate? So that is the ultimate kind of goal. We're taking a unknown, which is the gauge itself, and we're trying to compare it to a known reference, like a gauge block. Once that's been done, if adjustment is needed, it can be corrected, and that way we're working with a gauge that we can trust the measurements. A gauge R&R, on the other hand, it's answering a different question. It is this measurement system that we have in place adequate for the job? And that'll actually take into consideration a couple more factors than just the gauge itself. It'll also take a look at, are the operators, the people who are using that gauge, are they qualified? Are they using the right procedure for how to take the measurements? And even as Craig mentioned today, a lot of it has to do with the environment. Is the temperature, is the humidity off in that particular location? Are there vibrations? Is there dust? So that's almost taking a little bit of a step further than just the accuracy of the gauge, because I might have the most accurate gauge in the world in my hands, But if I don't know how to use it, it's still not going to give me sufficient or good readings.
So, and how is, so are these kind of two separate things, or are they related? I mean, if you're doing calibration, would you also do gauge R&R?
They are related. In fact, one of the big kind of keys is if you're going to do an R&R, you always want to make sure that you've done a calibration first on that gauge, because you don't want to be introducing other parts or other variation into that measurement study. So we first would do a calibration. That way we can be assured that the tolerances of that gauge are within the specifications and it is measuring accurately. And overall, what we're looking for is to make sure that the measurements that are being taken are going to be the best that they can be. And the other things are that to go with the R&R study is it's really just identifying the variation that you normally wouldn't find with just doing a calibration. So it's answering the same sort of questions, but it's also the different questions that are being asked. One's asking solely about the accuracy of the gauge, and the other one is asking about all the other factors that go into a measurement system.
And that leads me kind of to the next question, because I'm not always clear what this term means, but we run across the term measurement systems analysis, and what is that, and how does that tie into all this?
Well, measurement systems analysis, or sometimes referred to as MSA, these are a collection of studies that can be done on gauges and tools. All of this is kind of under the group called the AIAG, which is the Automotive Industry Action Group. And this represents kind of like the big three, Ford, Chrysler, General Motors. They came together to say we need to have some standard tests and methods for determining if gauges are the right gauges to be used for a particular project. So R&R studies, repeatability and reproducibility studies, it's one of the available studies that are underneath that MSA, or the measurement systems analysis. And there's a couple other types of studies, linearity studies, uncertainty studies, stability studies. Each of those has its own purpose and will be answering its own question about a particular gauge.
And does ISO 9001, I mean, do you know the answer to this question? Does ISO 9001 require any of these?
In general, ISO 9001, it will have some stipulations and some specific sections that talk about monitoring and measurement systems. On the draft of the 2015 version of ISO, as long as nothing changes dramatically, these sections are Section 7 and Section 9. So these give some sub-points about what a company should be doing when they're doing measurements and what sort of analysis they should be run through. For a more detailed explanation of specific needs for metrology for the science of measurement, a user might look at ISO 17025. And that one deals directly with what sort of things you should be doing for measurement equipment specifically.
Okay. Eric, thanks for answering all those questions. I think that gave us a lot of detail on it. Hang around just in case we get some more questions from our viewers. We've got about 7-8 minutes left in the show, so if you got any questions, send them to techno-live@qualitydigest.com, and either Craig will answer them, or Eric will answer them, or hey, who knows, maybe I'll answer them. We do have another question that came in last week. Somebody wanted to know what does proficiency testing interlaboratory comparisons mean? And this came from Jan Reynolds. And to answer that, I reached out to Albert Noyes, who's a manager of the Automotive, Military, Aerospace, EMC Performance group at Intertech. Intertech is a testing lab, if you guys aren't familiar with that. And I was hoping to get him on the show. I couldn't get him, but he gave me the short answer. So basically what we're talking about, proficiency testing interlaboratory comparisons, sometimes called a round robin. And essentially what is done is a golden part is sent out to several different labs. And all of the labs make a measurement or take measurements on that golden part and report their measurements back to whoever's coordinating the study, whoever the director of the study is. And so what they're looking for is ideally all well-run labs, all labs that are doing their job properly should all come back with basically the same results. If the director of the study sees that a lab is out of whack, then they need to look into it and find out why. Is it something to do with the environment? Is it something to do maybe with personnel training? Maybe they've had some personnel turnover. Maybe the person who's doing the measurement or whatever tests are being done aren't up to snuff, and so they're not doing their job properly. So basically, a round robin is just a way to look at the proficiency of labs, and if there is a lab that is not typical with the rest of them, then some investigation is needed to be done. And according to Al, he said there never is really a typical reason why a lab might be out of line with the rest of the labs in a study. He says there do tend to be some common causes. It could be equipment related, site related, personnel related. Equipment issues could be something, maybe something is starting to fail or drift out of calibration, hasn't been detected yet. Site related issues could be a case of a site-related issue might be a test utilizing a semi-anechoic chamber when the chamber is starting to failure, or an antenna could be bad. Personnel reasons could be, like you said, turnover, people haven't had enough changes, had enough training. The idea is that you want to kind of identify these labs that are out of whack, and it's kind of a check to make sure that the whole lab system is working right, because we all do. There's kind of this, everything is traceable to NIST, including Craig's lab. All of his measurements are traceable to NIST. There's this trust that goes on within the lab community that any lab is of equal value. I mean, you want to know that they're equal value. So this is a test that is done sometimes to verify that all the labs are operating within kind of the same, within the same bandwidth. Yeah. So, hopefully that answered the question out there. So if you have any more questions, I do have another question for Craig here before we go. But if you've got a question, we can squeeze one in at the end. Techno-live@qualitydigest.com. We didn't talk about accreditation.
Correct.
Lab accreditation.
Accreditation is something that a lot of customers will be considering when they're choosing a calibration lab. And the accreditation process is a very good process. It looks at all forms of the calibration
and we're
business.
talking 17025?
17025 is the typical one. There are others, but that's the one by and large most labs will be accredited to. A lot of the labs take the accreditation very seriously, and they put a lot of effort into making sure they're running within the parameters. There are unscrupulous ones that put all their time and effort into just passing the audit. So it's not a guarantee of a good lab, but it's a very good indication of it. How a lot of customers have chosen is to self-audit themselves. This way they're assured no matter what kind of accreditation you have, you're meeting their needs and you're doing the job they need you to do. So that is another method is auditing. The accreditation process itself is quite in depth, so it's a good indication.
So, but it's not necessarily an indication of if a lab wasn't accredited. It could be there just wasn't a need. They weren't being driven by their customers to be accredited.
It usually is
perfectly fine
driven.
lab, yeah.
Right. It's typically customer driven, and the customers that need it, they know it. They know they need it. There is no choice. There are some transportation or aerospace that it's absolutely required. There is no room for interpretation on the customer's end. They need an accredited lab.
Okay. So any more questions, Christopher? Nope, that's it. Okay, well that is the end of our show. We'd like to thank all of you for joining us, and also we would like to thank our sponsor for today's show, PQ Systems. It was PQ Systems who supplied us with Eric Gasper, our person who's more knowledgeable than us in Gauge R&R, that's for sure. Measurement systems analysis. So Eric, thanks for being on the show. For 30 years, PQ Systems has provided quality control applications and training to help people in manufacturing, healthcare, government, and service organizations demonstrate proof of their performance. Visit www.pqsystems.com to see the full range of products and services that PQ Systems offers. And again, thanks PQ for sending Eric our way. And Eric, thanks for joining us. Thanks for being with us on the show. And I think we have him offline now. I'm sure he said thanks. All right. So Craig, once again, thank you for a really informative show on what to look for when buying used gauges. Important stuff.
And thank you for your questions.
All right. We'll see you all at the next Gauging Quality. So long.
Three, two, one, fire.